Our test tomorrow will cover factoring. Factoring binomials and trinomials and four-term polynomials. The first thing you look for always is a GCF. Does this have a GCF? If it doesn't have a GCF and it's a binomial, then you look for the difference of two squares. For it to be the difference of two squares, it has to have, difference means subtract. It has to have a subtraction sign, and it has to have perfect squares. Is 25 a perfect square? Then it will factor into this plus minus pattern. Now, if you weren't sure that that was the answer, how could you check it? A box problem is a way to check it if you're not sure of your answer. If you have a trinomial, the first thing you look for is a GCF. Does this have one? No. Then you figure out the A, the B, and the C. You multiply the A times the C. The A times the C would be negative 20. The factors of negative 20 are 1 and 20 and 2 and 10 and 4 and 5. If B is positive, the biggest number is positive. The biggest number is always going to have the same sign as the B. If this is negative, they have to be opposites. Now that we have our factors, which pair can add up to get the B? Would this pair add up to equal the B? If the A is 1, you are almost done. Those are the factor numbers. How could you check it? Multiply out with a box problem. Now, you can only take those two terms and those two numbers and change them into factors if the A is equal to 1. If the A is not equal to 1, it's a little bit more complicated. So, we're just working on some notes I made up. They're not in the computer. They're up here on the wall. So, it doesn't matter whether you have a binomial or a trinomial or a bigger polynomial, the first thing you always look for is a GCF. Does this have one? No. So what's the A and the B and the C? We good on that? And then just like we did in the previous problem, you multiply the A times the C together. And I don't know what I was thinking when I made up this example because we have a large number here. But even if we have a large number, it doesn't take that long to fill in the factors. So we have the factors of 210 would be, of course, 1 and 210. And 2 and 105. And 3 goes into 21, so that would be 3 and 70. And so 4 also does 4 go into it? No. But 5 goes into it because it ends in 0, and so 5 would go into it. And so I figured these out ahead of time just to save time. And 7 goes into it. 7 goes into it 30 times. And 10 and 21 and 14 and 15. And so what I did to figure these out ahead of time is I took the 210 and divided it by 1 and 2 and 3 and 4. And when I divided by 4, I got a decimal number, so I want whole numbers. And 5 and 6. And so I did use a calculator to speed this up. So you can find the factors by taking this number and dividing, and if it comes out to be a whole number, it is a factor. Now, if B is positive, the bigger number is positive. If this is negative, they have to be different. Is there a pair here somewhere that can add up to get me 11? Now, most of your numbers would not be that big. And so, now, those are not the factors. You cannot take those two numbers like we did on the previous problem and say, here's my answer. The reason you can't do that is because if you multiplied out with a box problem, would this equal the 6x squared? No. It's more complicated when this is not equal to 1. So what I need to do is take these two numbers and these two numbers go in place of the 11x. Brian, there is nothing you're supposed to be doing on your computer at this time. So 6x squared is still here, and the minus 35 is still here, and we've divided that up. Now it's bigger and more complicated. But now I can divide it into two groups of 2. What is the GCF for this group, 6 and 10? 21 and 35. And whatever sign this is, that's the sign I'm going to use right there. The 2x gets factored out of this term. Can you find what goes in this parentheses? Do you know how to do that? 6 divided by 2 is 3. X squared divided by x cancels out one of those x's. 10 divided by 2 is 5. It's negative from that. The x's cancel out. This term factors out a positive 7. 21 divided by 7 is 3, and it has an x. 35 divided by 7 is 5, and it's negative because of that sign right there. If you have used the GCF and you haven't made a sign mistake, at this point, you should have a term that matches exactly, that gets factored out in front. Do you know where this other term comes from? If you multiply this out with a box problem, it would be equal, it would be the one we started with when you combine like terms. So, these are the kinds of problems that will be on the test tomorrow. So you are going to practice these kind of problems on the review today.